This is the AI briefing from Bosio.digital. Today, the developer world spent a week arguing whether AI agents should be loops or graphs. You may never write either one, but the day your one useful agent becomes five, you own the answer. On July 18th, Peter Steinberger, the creator of OpenClaw, who now builds agent systems at OpenAI, asked his feed a question that sounds like an inside joke. Are we still talking loops, or did we shift to graphs yet? Within days, it was the argument of the week. 2 days after the post, the project management company Linear shipped a feature literally named Loops. Nothing to do with the debate, but it poured fuel on it anyway. Essays followed. Camps formed. If you run a company rather than a codebase, your first instinct is the right one. This sounds like a developer's quarrel about shapes. Here's why we're covering it anyway. Underneath the jargon, the two shapes describe a decision your company is going to make this year. Probably without noticing it's being made. A loop is what you have when one AI agent does useful work. A graph is what you have the day your agents start depending on each other. And the research on what happens to companies that build graphs by accident is not comforting. So let's take it in plain language. Loops first, because you almost certainly already have one. In late 2024, Anthropic published a piece of engineering guidance that became the founding document of the loop era. Its core sentence: agents are typically just language models using tools based on feedback in a loop. Plain version. You give one AI a goal, access to tools, and a way to see the results of its own actions. It plans, acts, checks, and repeats until the job is done or a human steps in. One capable worker in a cycle. And full disclosure, as always, we build on Claude, so the loop philosophy runs deep in our own systems. You should know that as you hear our take on its limits. The loop's superpower is that it lets you defer architecture. You don't design a system, you hire a worker. One agent handles research, then drafting, then checking, until the day it can't. And you spin up a second agent, and a third. That day is where the graph begins. A graph in this debate means declared structure. Multiple agents whose relationships are decided up front. Who owns which task? What depends on what? What happens when a branch fails? Which agent checks which other agent's work? The essayist Carlos Perez, whose piece became the debate's intellectual spine, put the distinction in one line worth framing. Graphs are networks. Loops connected to loops with structure in the connections. The graph isn't a replacement for the loop. It's what honest loops become when there's more than one of them. Perez's essay is worth an executive's 10 minutes because it's really about improvement systems, not code. A single loop, he argues, fails in 4 characteristic ways. First, a metric optimized hard enough stops measuring what it once did. Second, a loop can't question its own target. Third, loops built independently fight each other. And fourth, the loop's own measurement decays, with no loop watching the watcher. His answer is structure. Paired metrics, audit loops watching operational loops, hierarchy with a purpose. If that sounds less like software and more like how you design a management system, that is exactly the point. Hold on to it. Now, before you buy any of this, you should hear the sharpest critique of the whole debate, because it's substantially correct. The writer behind the Turing Post newsletter looked at the graph excitement and said the quiet part precisely. None of this is new to software engineering. State machines, workflow engines, and orchestration systems have been doing versions of this for decades. And as she points out, mathematically, a loop is already a graph. It's simply a graph whose path returns to an earlier node. She also caught something worth respecting. A viral claim was already circulating that week, attributing spectacular accuracy and cost numbers to graph adoption at the major labs. And it was, in her words, simply not true. A debate 5 days old had already grown its own fabricated statistics. We checked her receipts. She's right on all counts. Graph orchestration tools have been shipping as products for years. So, is the whole thing vocabulary theater? About the words, largely yes. About the stakes, no. And here's the distinction that matters for you. when these patterns were engineering tools. The people making the structure decision were engineers, trained for it, inside systems that made the decision explicit. What changed is not the computer science. What changed is that AI made spinning up another agent so cheap that the structure decision migrated out of engineering to the head of operations who added a second automation, to the marketing manager whose assistant now feeds 3 other workflows, to the founder who bolted a 5th agent onto 4 others one Friday afternoon. The decades-old decision is now being made by people who have never heard the old names for it, at companies with no architect on staff. One convenient agent at a time. That's the new part, and that's you. There's a specific day this stops being abstract, and most companies can name it in hindsight. It's the day your assistant agent's output becomes another agent's input. The research agent feeds the drafting agent. The intake automation routes to the quoting agent, which triggers the follow-up agent. Nobody declared an architecture. The connections just accumulated because each one made sense on the day it was added. Congratulations, you have a graph. You just never designed it. If you heard our briefing on the 5 steps of AI adoption, this is the climb from step 2 to step 3, wearing different clothes. The moment one person orchestrating a few agents becomes a system where agents hand work to agents, the bottleneck stops being your attention and becomes trust and structure. And this is where the research gets useful because the failure patterns are no longer guesswork. In 2025, researchers at UC Berkeley and their collaborators did something nobody had done. They collected real execution traces from 7 different multi-agent frameworks, annotated them by hand, and published the first empirical map of how these systems actually break. 14 distinct failure modes. The useful part, they sort into 3 families that will sound familiar to anyone who has ever managed people. Family 1. System design failures. The organization was drawn wrong before anyone started working. Agents with vague roles, missing or conflicting instructions. Steps that end too early or never end. Structure was deferred, so the structure that emerged was accidental. Family 2. Misalignment between agents. The workers don't coordinate. One agent withholds context and other needs. 2 agents make conflicting decisions. Handoffs drop information. The team at Cognition, and you'll hear from them again in a moment, compress this family into a single line. Actions carry implicit decisions, and conflicting decisions carry bad results. And family 3, verification failures. Nobody competent checked the work. Checking steps that are missing, superficial, or themselves wrong. Systems that declare victory without grounds. In the data, this is one of the most common ways graphs die. The graph had no honest auditor. Notice something about all 3 families. None of them is a model problem. A smarter AI does not fix a wrong org chart, a broken handoff, or an absent auditor. These are design failures. And design is a responsibility, not a feature you can buy. Notice something else. The experts disagree about the cure. The team at Cognition, who build one of the best coding agents in the world, advise against building multi-agent systems at all for most work. One agent with full context beats a committee of partially informed ones. Anthropic's engineers, who built a multi-agent research system that genuinely works, report it excels where work splits cleanly into parallel pieces, and that it costs roughly 15 times the tokens, which means 15 times the compute cost, of a simple chat. When the 2 most credible builders of the Loop era disagree that visibly, the honest conclusion isn't that one of them is wrong. It's that the answer is structural, situational, and yours to own. Which brings us to the deepest point in the whole debate, the one the engineers keep stepping past. After making the case for graphs, Perez turns around and names the failure mode of his own solution. A graph of mutually checking loops can drift into what he calls circularity, a closed network of confirmations in which every part validates every other part and the whole thing slowly detaches from the world. His resolution, and it's the line to remember, the durable axis was never loops versus graphs at all. It is ungrounded versus grounded. Whether the improvement machinery keeps touching reality, And the ground, he insists, cannot be manufactured inside the graph. Some measurements must be the kind that cannot be argued with. Hear that with your company in mind, because it's the whole game. You can wire agents to check agents, add an audit loop, add a loop that audits the auditor, and at every level the same question recurs. What does this structure ultimately touch that isn't itself? In business terms, the customer who did or didn't buy, the invoice that did or didn't get paid, the claim a named human verified against the primary source. And here's the part we'd add to Perez. The same thing we found missing 2 weeks ago in our briefing on the 5 steps of AI adoption. The ground wire in a business graph is a human, a person with preserved judgment and a designed place in the structure. Not a human rubber stamping everything. That's just a slow loop. A human positioned at the anchor points, owning the definitions of good, studying the exceptions, empowered to overrule the graph and celebrated for it. Loops versus graphs is the engineering question. Grounded versus ungrounded is the business question. Your job was never to pick a shape. Your job is to be the ground. So what do you actually do? 3 honest answers by where you are. First, if you're running 0 or 1 real agent, stay in the loop proudly. The loop is not the junior version of the graph. It's the correct architecture for this stage. Postpone the structure decision on purpose and put your energy where we pointed 3 weeks ago. Defining good precisely enough that the loop can check itself. Second, if agents have started feeding agents, the graph already exists, so draw it, not in software. On a whiteboard, every agent and automation, every arrow of who feeds whom, and 2 notes per node. Who owns this and what checks it? Most leadership teams who do this exercise discover connections nobody decided, and at least 1 loop nobody is watching. That drawing is your real architecture. Every fix follows from seeing it. And third, this one is for everyone. Install the anchors before you scale the graph. 1 honest evaluation harness on your most consequential workflow. 1 human whose overrule is structurally welcome. 1 metric per major loop that cannot be argued with. Then grow the graph only as fast as the anchors grow. Remember the 15 times token math. Every layer of structure costs real money to run. Structure has to earn its seat, the same way headcount does. That was this week's briefing. Loops, graphs, and the ground wire the debate keeps forgetting. The full article is on the site. Every source, the Berkeley failure taxonomy, and a prompt you can paste tonight to map your own agent graph before it maps you. This has been the AI briefing from Bosio.digital, where AI transformation starts with your people. Thanks for listening.